right, my friends, welcome to Pre-Calculus Social Distancing Edition. We are going to start section 3B on polynomial functions. So when we last left off before your exam, we had been talking about quadratic functions, like we had maybe this quadratic function there. And now we want to say, can we graph it if we start adding on something higher, like an x cubed term, or maybe an x to the fourth term or an x to the fifth term? Like if we build up these exponents and get higher and higher, can we figure out what the graphs look like? All right, so to do that, these are polynomial functions. I want to take a step back and look at what we already know about graphing some simple polynomials. Okay, so it turns out that these lines that we know about are also polynomials, right? And when I want to graph these functions, these lines, I know they're lines because I look at them and they've got an exponent of 1, right? So I know it's going to be a line, and then I say that first function's got a slope of 2, so I know it's going to be rising left to right. The second function has a negative slope, negative 1/3, so I know it's going to fall left to right. So I can tell just by looking at the equation. And we kind of did the same thing with quadratics, right? We know that we see the x squared, we know it's going to be a parabola. The first function has a positive 2 out in front, so I know it's going to open upward. The second one has a negative 1, so it's going to open downward. Okay, and all I did to figure that out was looking at that first term in each equation. Okay, the exponent told me the shape of the graph. When it was x to the first over here, then I knew that it was going to be a line. And when it was x squared on the right, I knew it was going to be a parabola. And then whether the arrows were going up or down, I decided based on that number that was sitting in the front. The positive 2, the negative 1/3, positive 2, the negative 1. That told me whether it was opening upwards or downwards, or whether the arrows were pointing up or down. Okay, so it turns out that those two things are very important when graphing polynomials. The highest exponent, the highest power that you see, we call that the degree. Okay, so then the leading coefficient. Okay, so the highest power of x is called the degree, and the coefficient of the highest power of x is called the leading coefficient. Okay, so all lines are what we call degree 1 polynomials, and all quadratics are degree 2. Okay. All right, so we really need to get these terms down, the degree and the leading coefficient. So let's just do an example of that real quick. All right, so state the degree and the leading coefficient of the function. All right, and so you really just want to scan and find the biggest exponent you see. All right, the exponent is what we call the degree. So this is a degree 3 polynomial, and the leading coefficient is equal to 2. All right, then the next one, again, if I'm trying to be sneaky, I kind of buried the biggest exponent there in the middle of the function. Okay, so it doesn't always have to be the first term. This one is a degree 4 polynomial, and its leading coefficient is equal to, not 2, it's negative 6. All right, whatever number is stuck to the highest power of x is your leading coefficient. All right, so you're just looking for the biggest exponent and the number stuck to it, and that gives you the degree and the leading coefficient. The last one, I'm being kind of tricky here. This is h of x equals 3. That's really the line y equals 3. It's just a horizontal line. We already know a lot about that function. All right, but we would call this a degree 0 polynomial because it's kind of like there's an x to the 0 here. Remember that in your exponent rules, anything to the 0 is equal to 1. All right, so there's kind of this x to the 0 that doesn't need to be written there. All right, so we would say that this is a polynomial of degree 0, and that its leading coefficient is equal to 3, the only coefficient that's there. All right. Okay, so that's our basics of polynomials, the degree and the leading coefficient. But also notice these polynomials just have these terms x to the n, x squared, x cubed, x to the fourth, or an x to the fifth. where n is a positive number. So you're never going to see an absolute value. That would not be a polynomial. Polynomials don't have square roots in them. They don't have weird exponents like decimals or fractions or negative numbers. They only have these nice whole positive exponents. All right, so that's what the equation of a polynomial looks like, and we can now identify its degree and leading coefficient. Now I want to go over to Desmos and look at, let's see. All right, I just kind of want to get you an idea of what the graphs of these polynomials look like. So I have this whole pile of them over to the left. All right, so I've got x cubed. That's one that you're familiar with. It looks a little squished because if you look at my y-axis, I have it going from negative 40 to positive 40. That's because polynomials tend to get gigantic y-coordinates. All right, so I've got another x cubed, a degree 3 polynomial. There's another degree 3 polynomial. This is going to start to look like spaghetti. Let me turn that off. All right. All right, so they can kind of wave around. They kind of look like roller coasters. All right. All right. And then x to the 4th. There's another roller coaster. Another x to the 4th. All right, so we really can't predict the shape of these necessarily. They can get pretty wiggly, especially when you start to add on an x to the 5th, x to the 6th. Okay, that one is wiggly but very flat. Yeah, so you can kind of see they take all different kinds of shapes, but they do have a few things in common. Right, so I'm just going to turn all of these on and look at the big pile of spaghetti. All right, so that looks like a big mess. Okay, but look at all of them. They all have in common that they're very wavy and bumpy, kind of like a roller coaster. And they all kind of go off screen on both sides. From left to right, they either end up going up to positive infinity or down to negative infinity for their range. Okay, so let's see. Let's get back over to our slides here. All right, so we say that a graph of a polynomial is always smooth and continuous. Okay, so kind of keep that roller coaster graph in your mind, something like this. Okay, so not like an absolute value graph. They're never going to have a corner. These polynomials are never going to have a sharp corner in them. That would not be smooth. So by smooth, we mean that wavy sort of roller coaster shape. And they're never going to be like our piecewise functions where there's some sort of gap or break in them or where they stop. They're going to keep going smoothly. You can draw them from left to right with your pencil without lifting it up. All right. Okay, so those are our polynomial basics. We know how to identify the degree, the leading coefficient. We can recognize their formula, and now we can kind of recognize what their graphs look like. All right, so in the next video, we'll move on to how to determine what the end behavior of a polynomial is.